Mic. Good morning, students. I hope you all are well. Today we're gonna start our new topic called chemical effects of electric current. In this particular topic, we're gonna study about how the chemical effect can be seen whenever an electric current is passing through a solution. Whenever there is a solution and when we are passing electric current to it, we are having some chemical reaction to it. Okay, so this whole phenomena is called chemical effect of electric current. So in today's topic, we're gonna see some examples. We're gonna discuss about good conductors, poor conductors, what are good conductors of electricity, what are poor conductors of electricity, what makes them a good conductor or what makes them a bad conductor of electricity, how a solution can conduct electricity, what makes a solution to conduct electricity, and if there is electricity, what chemical effects we can see in that solution. So all these topics we're gonna discuss in today's class. So again, a very good morning to all of you. Let's start our class. Conduction of electricity. Similar to many solids, some liquid also conduct electricity. Now about the solids, we have discussed in our earlier classes that all metals are good conductor of electricity. Whenever electricity is passed through them, they show good conductance of electricity. Electricity can be passed through the metals. Okay, in the same way, when we talk about plastic, woods, these all are bad conductors of electricity, or we have given a name insulators. So conductors are those in which electricity can be passed, and insulators are those in which electricity cannot be passed. Okay, so some materials are good conductors of electricity and some are bad conductors of electricity. So here we are talking about solids. In the same way, liquids also can conduct electricity. How liquids can conduct electricity and which liquids can conduct electricity? Let's see. Conductors, substances which allow electricity to pass through them, are called conductors, such as silver, gold, acidic solution, salt solution, etc. So these are the conductors which can allow electricity to pass through them. Some examples are metals, salt solution, acidic solution. These all are the good conductors of electricity. In the same way, insulators or bad conductors of electricity, substances which do not allow electric current to pass through them, are called insulators, such as plastic, rubber, etc. In your previous classes, you have made a tester, and by the tester you are checking which substance are good conductor, which substances are bad conductor of electricity. So now let's discuss about what is a tester, because whatever theory we have seen, like metals are good conductor of electricity and plastics are bad conductor of electricity, on what basis we can say that? Of course, we have done some activities, we have done some experiment to so that we can understand that these metals are good conductor, whereas plastic and wood are bad conductor of electricity. So for that activity, for that experiment, we have prepared a tester. A tester is used to detect whether a substance can conduct electricity or not. How can we make a tester? What is the work of a tester? Let's see. What is a circuit tester? Use of a circuit tester to test whether the material is a good electrical conductor. Example of a circuit tester. You can see here the example of a circuit tester. Here is a tester. Okay. Now you can see this is the battery. This is the bulb. These are the wires. Now when nothing is connected to these wires, you can see there is a little bit space between the wires. So we all know that air is a bad conductor of electricity. If air is a good conductor of electricity, we can see that this bulb started glowing. But this bulb is not glowing because our circuit is not complete. This is an incomplete circuit. So when the bulb is not glowing, air being a bad conductor of electricity, we cannot see the bulb glowing. If we are putting anything which is a good conductor of electricity, suppose I am connecting these two wires with a metal piece. Suppose iron I am connecting. I have taken an iron piece. Now I am testing whether it can conduct electricity or not. Now this circuit is incomplete, current can flow through all the wires, and now the bulb is also glowing. So these all are the examples. This is a tester. this tester can used to detect the electricity, okay, whether electricity is flowing through any material. Okay, so this is the tester. Now, how to use a circuit tester? Step 1, set up the circuit tester as shown above. Step 2, place the object between the open ends of the wire or crocodile clips. You can see here he has taken a screw. Okay, now a screw is basically made up of iron. Usually it is made up of iron. So when a screw is is placed in near the two ends, when these two ends is connected to the screw, the bulb started glowing. Screw being a good conductor of electricity, is the material being the iron being a metal. All metals are good conductors of electricity. So by seeing this example, we are using the tester basically. Okay, how can we use a tester? How to use a circuit tester? If the bulb lights up, it means the material allow electric current to flow through the closed circuit. If we are connecting two ends of the wire to any particular material, and if we can see the bulb is glowing, so yes, our tester is working. Okay, now if the bulb is glowing, it is showing any particular material is a good conductor of electricity. And in the second case, when the bulb is not glowing, the brighter the bulb, the better the conductor of the electricity is the material. Suppose I have joined two wires with the silver or gold, silver being the best conductor of electricity. Now if we are connecting two wires with the silver, we can see the bulb brighten up, and if we are putting these two wires in a salt solution, we can see the bulb is lightening up, but not to that extent. Okay, so when electricity is passing through the silver being the best conductor of electricity, we can consider that the material is the better conductor. But if we are dipping these two wires in a salt solution cannot pass. It can pass only weak current. So by using the tester, not only we can detect whether a material is a good conductor or bad conductor, we can detect a material is getting a weak current or a large current or a good current. Okay. Now let's discuss some other examples. Suppose right now we have seen that metals, suppose I am talking about iron being a good conductor of electricity. When we are connecting these two wires with the iron, the bulb will glow. But suppose you are connecting these two wires with the iron piece, then also bulb is not glowing. So what ideas you can give so that the bulb start glowing? What ideas you can get? So first let's see the tester. Suppose here I have connected an iron piece. Now in the previous activity we have seen connecting iron piece make the bulb glow. Iron is a good conductor of electricity. But suppose next day you are connecting iron piece to this circuit, to the tester, but the bulb is not glowing. So what things we can consider? First thing is, our bulb may be fused. If the bulb is fused, of course that time also circuit is not completed, because the filament is broken. Then the circuit is not completed and the bulb will not glow. Because the circuit is not completed, current cannot flow between it. Second case, the battery can be used up. Battery can be used up because suppose the bulb is not glowing, bulb is in a good condition, but suppose our battery is used up, then also it cannot complete the circuit, current cannot flow between them. Then that is the second case where the bulb will not glow. Or the third case will be the wires can be loose. The wire which is connecting, they can be loose. So here are the certain conditions whether being a tester, if we are testing our tester and the tester is not working, then also we can consider these situations, and if these three situations are completed, then we can again use our tester for different purposes. Okay, so this is basically our Now, good conductor and bad conductor. Substances which allow electric current to pass through them easily are called good conductor of electricity, such as silver, gold, aluminium, etc. Now we have made a tester. We can test certain materials if they are a good conductor or if they are a bad conductor. So now when we are testing certain materials, we can see that some materials are good conductor whereas some materials are bad conductor. Here are some examples: silver, gold, aluminium. These all are the good conductors of electricity. Some substances allow electric current to pass through them, but in very little amount. Therefore, such substances are called bad conductor of electricity rather than being called insulators. Now, some substances, they certainly in some conditions they allow electricity to pass through them. So we cannot consider them as a bad conductor of electricity. We use different words for them. We cannot use insulators for them. We are using a different word, bad conductor of electricity, because insulator means they are evenly not conducting electricity. For example, air being a bad conductor of electricity, because if I am not joining two wires of a tester, the bulb is not glowing because there is air between them. Suppose here are the two wires and I am not joining these two wires. Now the gap between these two wires is the air. If air being the good conductor of electricity, our bulb will be glow. But our bulb is not glowing. So air is a bad conductor of electricity. But in certain conditions, like at the time of thunderstorm, air can conduct electricity. We can see thunder can getting down to the ground from the clouds. The thunder is touching the ground. In that case, air is conducting electricity. So that's why we can say that at certain conditions some materials can conduct electricity. So that's why we are not using word insulator for them. We are using bad conductor of electricity for them. Okay. In fact, most of the substances allow electric current to pass through them under certain conditions. So instead of using terms conductors and insulators, good conductors and bad conductors are used. Okay. So whenever you are considering some situations, don't use conductor or insulator. Instead, you can use good conductor of electricity or bad conductor of electricity. Okay. Now, electric conductors are materials that allow electric current to flow through. Examples are salt water, metals such as copper, aluminium, and non-metal like graphite, a form of carbon. Now, we have studied that all metals are good conductors of electricity and non-metals are bad conductor of electricity. But a non-metal called graphite is a good conductor of electricity. It is basically a form of carbon. Now, graphite can conduct electricity. Okay. Being a non-metal, graphite can conduct electricity because graphite has free electrons to pass through them. So, graphite can conduct electricity and it is the only non-metal. So whenever you are seeing in a question in your exam, a non-metal which can conduct electricity, your answer will be graphite. Okay, graphite is a good conductor of electricity and it is used in the pencils. Okay, graphite is used in the pencils, the lead of the pencil. You are writing the help of the pencil, that black substance is graphite. Okay, it can conduct electricity. Copper, silver, aluminium, graphite, these all are the good conductors of electricity. Electrical insulators are materials that do not allow electric current to pass through them. Electrical insulator, we have used the word insulator by the word bad conductors of electricity. Insulators are those which cannot conduct electricity. Okay, here are some examples: plastic, wood, rubber, glass. These all are the example of insulator. They cannot conduct electricity. Okay, in certain conditions also they cannot conduct electricity. So yes, we can use insulators for them. We can use the word insulator for them. But air is a bad conductor of electricity. Air is not an insulator. Air is a bad conductor of electricity. Okay. Here is a rubber, plastic, wood. They all cannot conduct electricity. Now till now we have understood about the conduction of electricity in solids. Now we are understanding the conduction of electricity in liquids, whether liquids can conduct electricity or not. For doing this, we have to perform an activity. Okay, which activity we have to perform? Liquids which contain salt dissolved in them conduct electricity. The conduction of electricity through a liquid can be tested using two electrodes and a bulb. If a liquid contains some salt solution, if a liquid can contain some ions, some salt solution, like if I am dissolving, okay, so if in a liquid, if there is a salt solution, if it is an acidic solution, then it cannot conduct electricity. Okay, suppose we are having a distilled water, and if I am checking the conduction of distilled water cannot conduct electricity. Okay, if we are putting our two free ends of the wire of the tester in the distilled water, that distilled water cannot conduct the electricity because there is no salt, so there are no free ions to pass electricity. Okay, so distilled water is a bad conductor of electricity. But if we are dissolving salt or acid in that or some base in that distilled water, then it can start conducting electricity. Okay, but the conduction of electricity through the liquid, which are poor conductor, cannot be tested. But conduction of electricity through such liquid can be tested using LED or magnetic compass needle. For this you need a compass needle, an empty matchbox, two electric cells, some wires, a plastic bottle caps, and the liquid which is to be tested. Keep the compass needle inside the empty tray of the matchbox and wrap a couple of rubber band around it. Connect the wire to the battery and insert two wires in the liquid which is kept in the plastic bottle cap. You will observe that when the current flows through the wire, there is a deflection in the compass needle. This shows that the given liquid conducts electricity. In fact, magnetic compass needle can detect even feeble current. LED can also be used in place of compass needle. Now, suppose we have, suppose this is a bulb, this is the battery, here are two free ends of the wire, here is the salt solution, okay. Now we have seen that distilled water is not is a bad conductor of electricity. This is the battery. Now we know that distilled water is a bad conductor of electricity. Now suppose I have dissolved some salt in that distilled water. Now it is a good conductor of electricity, but in this case also our bulb is not glowing. Okay, we have checked all the connection, our bulb is in a good condition, our battery is also working, the wires are connected in a good way, but then also our bulb is not glowing. So what conclusion we can get? That this salt solution is getting very weak current, and bulb cannot detect weak current. So that's why in a tester we have to use certain different items instead of bulb. Now what we can use? Now there is a magnetic needle, magnetic compass. There is a magnetic compass. It is like this. A magnetic compass is like this. It has north pole, south pole, and a magnet is like this, magnetic needle. Okay, a magnetic compass is like this. Now in your previous classes you have studied about magnetic effect of electric current. Whenever there is electric current passing through any conductor, it produces some magnetic effect. Okay, we have prepared electromagnet. If you have remembered in class 7, we have taken an iron nail and we have a coil copper wire in that iron nail, and then when the electric current is passed through that iron nail, that iron nail is behaving like a magnet. Okay, so whenever electric current passes through any conductor, it behaves like a magnet. Now instead of this bulb, let's use this bulb, let's use a magnetic compass, which we have taken in a matchbox. Okay, we have coiled the wire. Okay, now when the two wires are dipped in the salt solution, the magnetic needle show deflection, which shows that this salt solution is a good conductor of electricity, because this magnetic needle can detect weak current also. It can detect some weak current. So this is also an example. Now suppose magnetic compass is not available. What we can use? We can use an LED. An LED is basically light emitting diode. It is like this, which is having one end and one shorter end. Okay, it's an LED. The longer end is a positive terminal we can connect, and the shorter end is the negative terminal which we have to connect from the battery. Now instead of this magnetic compass, we can use that LED also, because LED also can detect weak current. Okay, so if the bulb is not lightening even when you are dipping your two free ends of the wire in the salt solution, it doesn't mean that salt solution is a bad conductor of electricity. It means that it is producing very weak current. Understood? Now this is the magnetic compass. As you can see, this is the magnetic compass. Okay, this is the magnetic compass. Now salts dissolved in water are responsible for conduction of electricity through water. Tap water, acid solution, basic solution, etc. are good conductors of electricity. Distilled water is poor conductor of electricity, because in no salt is present in the distilled water. Distilled water is not that water which you are getting from the tap. Tap water contains some minerals and some salt. Now it doesn't mean that tap water is not pure water. It contains some salt and minerals which are beneficial for your health. All the person they are not drinking distilled water, because drinking distilled water cannot give us certain minerals. If you are drinking the water which contains some minerals and salt, that will be good for our health also. It has some good benefits. Okay, so distilled water you can purchase from a medical store. Okay, you can get from a drug store easily. Okay, and distilled water is available in our science lab also. Now when we are checking the conduction of electricity in a distilled water, we can see that distilled water is not conducting electricity. Okay, so to make distilled water a good conductor of electricity, we have dissolved some salt in it. Okay, because when salt is dissolved, the free ions get into the liquid, and these free ions can conduct electricity. Now it is not necessary that we are just dissolving salt. We can take acid also. Okay, we can add some amount of hydrochloric acid, some amount of sulfuric acid. Like if we are testing the conduction of lemon juice contains citric acid. Okay, so if we are checking the conduction of lemon juice, of course it can conduct electricity. Okay, now let's talk about vegetable oil. Vegetable oil cannot conduct electricity. It does not have any certain free ions, and it cannot conduct electricity. Same with the honey. Honey also cannot conduct electricity. But if we talk about milk contains lactic acid. So acids being a good conductor of electricity, milk can also conduct electricity. Lemon juice can conduct electricity. Tap water, it has some minerals and salt, it can also conduct electricity. So these are some examples where it can be seen that some water can be a good conductor or bad conductor of electricity. Now test electrical conductivity of liquid. Place the two aluminum plates into the liquid tested. If the bulb lightens up, a closed circuit is formed, allowing current to flow through it. The liquid is a conductor of electricity. Now here you can see we have prepared a circuit to test the conduction of electricity. We have taken two aluminum rods. These are two aluminum rods. We have taken a bulb, we have taken a battery. Now when we are putting these two aluminum rods in a certain liquid, we can see that bulb is lightening up, and then we can say that whether certain liquids are good conductor or bad conductor of electricity. Some liquids are good conductors of electricity. Example: tap water, salt solution, hydrochloric acid, sodium hydroxide. Sodium hydroxide is a base. Solution of acid, base and salt are conductor of electricity. Remember this line. This line is very important. Solutions of acid, bases and salts are the conductors of electricity. Remember this always. Okay. These are the conductors of electricity. Now, some liquids are poor conductor of electricity. Example, distilled water, sugar solution, kerosene, spirit, etc. These are some bad conductors of electricity. Okay. Like here we can see there are some diagrams which you can see. Please wait a minute. Now, if we are comparing these two diagrams, here we can see that the bulb is glowing. But in this case, the bulb is not glowing. So, of course, the two solutions are different. One solution contains some salt, some acid, some bases, and the other solution is a kind of distilled water. It can be honey, it can be vegetable oil, it can be a sugar solution. So that's why our bulb is not glowing. So by comparing these two diagrams, you can easily say that which are the good conductors and which are the bad conductors of electricity. Now second, molten sodium conducts electricity. These are the metal rods. These are molten sodium chloride, okay, which is dissolved, sodium chloride which is dissolved in the water, battery and the bulb glows. So by seeing all these examples, we can say that some liquids can conduct electricity whereas some are not. Chemical effect of electric current. Now till now we have understood what are the bad conductors, what are the good conductors, what some solids are good conductor or bad conductors, whether some liquids are good conductors or bad conductors. About the solid we have understood in our earlier classes also, like in the 6th class, 7th class we have understood about the solids, they are good conductor or bad conductor. Now in this class you are understanding about the liquids also. So about the liquids we have understood that acid solution, salt solution, base solution, these all are the good conductors of electricity. When electric current is passed through a conducting solution, some chemical reaction takes place. Now about the liquid we have seen they can conduct electricity. What happens when the electricity is passed through the liquid for the certain period of time? Okay, now what happened to it? Of course, it can show a chemical reaction. That is an example of chemical effect of electric current. You can see in the word chemical effect of electric current. When an electric current is passed through a solution, it shows a chemical effect. That is an example of chemical effect of electric current. Okay. Examples: when electric current is passed through water, water dissociates into hydrogen and oxygen. Hydrogen is deposited over negative pole and oxygen is deposited over positive pole. Deposition of hydrogen and oxygen at different poles is visible in the form of bubbles. Now we have tested. Let me show you. Yes, this is the example of chemical effect of electric current. First, let's discuss about the whole. Second, when electric current is passed through the solution of a metal, salt such as solution of copper sulfate metal get deposited at the negative pole because metal is positively charged. This is known as electroplating. When a metal is poured into a liquid and the liquid is also a salt of that particular metal. Suppose I am using copper rods and the solution I have taken copper sulfate. Now we can see that the copper is deposited over another pole. Okay. So this whole phenomena is called electroplating, when a desired metal is submitted over another particular metal. Okay. Deposited over a metal. That is called electroplating. Second is sometimes the color of solution also changes when electric current passes through it. Of course, certain conditions, whenever there is a chemical effect takes place, it can change the color of solution as well. And the next is, the above examples are some of the chemical effects of electric current. The chemical reaction depends upon the type of solution which we have taken. Of course, the chemical effect depends on the type of solution we are taking. If we are taking another type of solution, it cannot show the chemical effect. Now, by the diagram we can see. See, the rod which is connected to the positive end of the battery is known as anode, and the rod which is connected to the negative end of the battery is called cathode. So when suppose water we have taken, water, to make it a good conductor, we have dissolved some salt. Okay, so now it's a good conductor of electricity. When the salt is dissolved, you can see now when the salt is dissolved, you can see after some time, not immediately, after 15 to 20 minutes, we can see that some bubbles over the rods. You can see these bubbles. Now in the water is made up of H2O, hydrogen and oxygen. The formula for water is H2O. Now we can see bubbles of oxygen over the positive end of the battery and bubbles of hydrogen at the negative end of the battery. So passing electric current has dissociate water, the element of water. So this is a particular chemical reaction taking place in the water. So that's why the name is chemical effect of electric current. You can see the bubbles. You can also do this activity at your home. The activity is very easy. So this is the whole phenomena of chemical effect of electric current. Okay, I hope you have understood. Now electroplating. Electroplating is used to deposit a layer of metal on the other metal. Suppose we are taking a copper plate and we are depositing the copper on the steel plate. We want to deposit copper on the steel. So in that case, that phenomena is electroplating. Okay, we will use the solution of the desired material. Okay, so these all are some examples of electroplating. Process of electroplating, you can see here, negative end is this, positive end is this. So if we want to deposit this metal on it, we connect negative end. Suppose I want to deposit copper on the steel, so we'll connect steel to the positive end, we'll connect copper to the negative end, then this copper will start depositing on the steel. Okay, this is the whole process of electroplating. So I hope whatever the topics we have taken today, you all have understood these topics about the conduction of electricity in the solid, about the conduction of electricity in the liquids, how liquids can conduct electricity, what is there in the liquid which makes it a good conductor or bad conductor of electricity. All these topics we have covered in today's class. We have seen some chemical effects of electric current, how a chemical effect is seen when an electric current is passed through a solution, how solution behaves, whether it is a good conductor or bad conductor. So these are all topics we have seen in the today's class. I hope you all have enjoyed today's class. You have understood whatever topics we have seen. So thank you everyone. Have a nice day. Please be healthy. Please be safe at your home. Thank you.